So f of x equals negative 1 over x, and the point is given to us, negative 1, 1, correct. So y minus y1 equals the slope times x minus x1. I already placed x1 under x1, in other words, negative 1 under x1 and 1 under y1. So what I need to determine is the slope. No problem, because I know that when I differentiate this function, I get 1 over x squared. When I differentiate 1 over x, I get negative 1 over x squared. But when I differentiate negative 1 over x, I get positive 1 over x squared. All I have to do is plug in negative 1. So f prime of negative 1 happens to be 1. Because negative 1 squared is 1, 1 over 1 is 1. So that's all I need. So I have y minus 1 equals x plus 1, careful, minus minus. So then I only have to move negative 1. So y equals x plus 2. What is this? This is the equation of the line tangent to the graph of this function at this point. So if you, again, allow me to just give you an idea. So this is 1 over x, but negative 1 over x is this. This is the graph of negative 1 over x. So at this point, at negative 1, 1, somewhere here, at negative 1, 1, if I draw the tangent line, the tangent line has this equation. Okay. Anything? Any questions here? Okay. What about marginal cost, marginal revenue, which are just the derivatives? I'm looking on page 305. We graphed the function last time. We know how to find the horizontal asymptote. Let's look at the average profit. So remember, the average profit function is profit over x. The average cost function is cost, total cost over x, and so on and so forth. Would you like to look at the total cost and revenue?
Yes. Can we look at that?
Yes.
55?
Yes. Perfect. So I don't want to forget, Thursday we will continue on our final exam review, so you know that, please. So we have C of x, so this is 55, and the page is 305. So C of x is 5,000 plus 6x, and R of x, the revenue, is negative 1/2 x squared plus 1,000x. Find the total profit function, and then find the average profit function. Okay. So the profit function is revenue minus cost. I have to copy this function, and minus cost means minus minus. So negative 1/2 x squared plus 1000x minus 5000 and minus 6x. So negative 1/2 x squared, 1000 minus 6 is plus 994x, and minus 5000. So I have the profit function. Now they want us to determine the average profit function, not the average rate of change, not the average value of the function. No, they want us to find a new function, which is the average profit, which is this function divided by the number of units produced. So as you saw, sometimes you don't need to use this notation. Sometimes this is denoted by p of x with a bar on top. Not important. So negative 1/2 x squared divided by x is negative 1/2 x. 994x divided by x is positive 994. And minus this over this has to stay as is. Now, the question normally will ask us to find the rate of change. Rate of change of this function is p of x over x, everything prime. So I'm going to find the derivative of this function, which is negative 1/2. This is 0. And remember, negative 1 over x prime is positive 5000 over x squared. So this is the rate of change, is the derivative of this function. And now I may be asked to evaluate it. I may be asked to find its maximum, and so on and so forth. All sorts of questions may come up. Any questions? Any questions, please? Now, the question here is still asking us to find the slant asymptote for the graph of this, of the average rate, and this is the slant asymptote. This one. I will not ask you to find the slant asymptote, but this is the slant asymptote. Just the quotient of the division. So y equals negative 1/2 x plus 994 is the slant asymptote. I will not ask you to graph something like this. It's not a difficult situation, but it's not something that we spend a lot of time on. We spend a lot of time on graphing simpler functions than this. So I'm happy with that. Do we need to go back to integration? Chapter 4. We looked last time at a few examples when we looked at the approximating integrals. Do we need to go back to integration?
Yes, can we look back at some of those?
Sure. So let me look. So the chapter review, there is a chapter review, 463. Okay, so we have the indefinite integrals here. We have some definite integrals here. We have more indefinite integrals here. Of course, we are limited to 4.1 through 4. So 4.6 is integration by parts. We did not address that. So if we hit something like that, then I'll have to, we have to choose a different problem. So we cannot choose from 4.6. We did not look at integration by parts. It's not part of the class. I just wanted to give it a heads up in case we choose something. Okay. Any preference, or I will choose?
Do we look at indefinite integrals first?
Yes. From here or from here?
So can we try 52?
Yes, of course. 52. And I'm on page 7. 52 on page 464. So we have the integral from natural log of 7x dx. Unfortunately, this is part of 4.6. It's integration by parts. We cannot do this one. Sorry. Integration by parts is basically when we integrate a product. So I have to change this function into x prime times natural log of 7x, and then take it from there and apply integration by parts. But we have not studied integration by parts in this class. Sorry about that. So that's why it says here at the top 4.3 through 4.6. So let's choose something else. So 52 and 53 we cannot choose.
49.
49, yes, 49 works. 49 on 464. We have the integral from 5x to the 4th e to x to the 5th dx. So this is a typical situation for substitution. I'm going to say let y equals x to the 5th, because dy is 5x to the 4th dx. And this is exactly what I need. So 5x to the 4th dx is just this. So therefore, the integral reduces to e to y dy, which is extremely elegant. This is a mess, but this is extremely elegant. E to y dy. So when I integrate that, I just simply get e to y plus a constant c. And of course, I have to go back to the variable in the problem. So once you found the substitution, sometimes more than one may work, the whole thing is straightforward, I think. So that's with the indefinite. Now, if you'd like to choose another, please do so. Now the definite integrals. Where are the definite integrals? Did they forget about definite integrals? Oh, where are they? What's going on? Okay, here. 20 through 25.
Can we do 23?
Yes, of course. Let's look at 23. This is one of the properties of the definite integral. Oh, I was looking at 25. Sorry. So the integral from 0 to 1 from e to 2x plus x dx. Perfect. I thought for some reason I looked at 25. And that's a property of the definite integral. Okay, good. So we know that e to 2x divided by 2 plus x squared over 2 is the antiderivative of this function. How do I know? When I differentiate e to 2x times 2, and I simplify and I get that. When I differentiate this, I bring down 2, simplify, and I get that. So this is the antiderivative of this function. But now I have to plug in 1 and then subtract when I plug in 0. So when I plug in 1, I have e divided by 2 plus 1/2 minus. When I plug in 0, I have 1/2. And when I plug in 0, I have 0. These two go away, so the answer is, e divided by 2. Any questions? Okay. Do we still need to look at integration? Definite or indefinite? So here for 25, since I mentioned 25, you see there is a break in the middle, and the break is at 0. So you will have the integral from -2 to 0, from x plus 2, plus the integral from 0 to 4 from the other one. You just have to calculate two integrals. Find the average value of a function on an interval. This is part of our class. It's just a simple formula. Do we need to work on this?
Yes, could we try that one?
Yes, of course. So we have the average value of y equals x e to negative x on the interval 0, 2. And this is 44. Okay. Good. So the formula for the average value, f average, on the interval 0, 2, is 1 over 2 minus 0, the integral from 0 to 2, from x e to negative x dx. There may be a problem, although they wrote 4.4. I would have used integration by parts here. I don't think it works with substitution. Let me see for a second. I'm afraid they're wrong. I know they said 4.4 because this is the formula. But there is a problem. So this will be the integral from 0 to 2 from x negative b to negative x prime dx. So I don't think this will work with anything else but integration by parts. You do not have to do this, of course. Yes, it will not work with anything else. So unfortunately, we have to use integration by parts. So it's a product of two functions. So what we do here is I'm changing this into a derivative, and then I apply a rule. I don't want to confuse you. So we have to choose a different function. So let's come up with a different function and determine they're wrong. So let's choose a different function to find its. So yes, they wrote 4.4 here, but it doesn't work. Finding the antiderivative of this function requires integration by parts. Okay, so we can make up a function. It doesn't matter. So let's say f of x equals e to negative x plus 2x plus natural log x. Now let's say on the interval 1, 2. So f average is 1 over 2 minus 1. The integral from 1 to 2, from e to negative x plus 2x plus natural log x dx. Okay. We are able to determine this straightforwardly, the antiderivative of that function. So negative e to negative x plus 2x squared over 2. Again, I chose something that we don't know the antiderivative of natural log. We have to use integration by parts. So I have to change this into 1 over x. We don't know how to determine, we have not studied in this class how to determine the antiderivative of natural log. Okay. I don't have a function whose derivative is natural log. Good. So then plus natural log x. Okay? From 1 to 2. We know the natural log, of course, the absolute value, but it's 1 to 2, so it will be positive. But so natural log of absolute value prime is 1 over x. Good. So now what I have to do is plug in 2 everywhere. Negative 1 over e squared plus 4 plus natural log 2 minus, when I plug in 1, 1 over e and plus, I already said it was minus with minus in front, so now I have to go along with the initial idea. Okay, so this is plus. And then it's minus 1. And when I plug in 1 here, it's 0. Natural log 1 is 0. So this is minus. Okay. So now perform the calculations as much as you can. Of course, negative 1 over e squared has to stay, and then plus 3 plus natural log 2 plus 1 over e. There is no need to approximate. That's the exact average value of this function on the given interval. Okay. Anything from chapter 6 we need to look at?